Hi, everyone. Thanks for spending some time with us today. We're here because we're focused on addressing the most challenging security issue for any organization operating at scale in the cloud: infrastructure misconfiguration. You should see a poll on your screen, and we'd love to know how much time on average your team is spending managing this problem. The good news is that it doesn't necessarily need to be this way. Cloud misconfiguration is entirely preventable, and that's what we're going to focus on. First, Fugue's co-founder and CTO, Josh Stella, is going to talk a bit about the problem we're addressing and why it can be so dangerous and frustrating. Then, Ricardo Green, one of our security solutions architects here at Fugue, is going to show some misconfiguration in action, and he's going to do it live against a running Amazon Web Services cloud environment. We'll then compare two different approaches to the problem: one using automation scripts to remediate misconfiguration, and the other self-healing infrastructure that enforces a known good infrastructure baseline. And before we get to Q&A at the end, we're going to return to our AWS environment to see how self-healing infrastructure withstood the chaos that Ricardo unleashes. So with that, I'm going to throw it over to Josh. Take it away, Josh.
Thank you, Drew, and thanks everyone who's joined us today. So let's jump in. So we're not going to do death by PowerPoint today. There will be some slides, but we're going to show you a lot of live demo and some source code too. And I promise for those of you who aren't programmers, I'll explain through some of the source code in a meaningful way. So what we're talking about here is cloud misconfiguration. And this is a really big security risk. So a lot of the data we're going to show you through this presentation, like the 93% concern for major security breach on the right, comes from a survey we did of over 300 cloud practititioners who are operating at scale. And when we published the results of that survey a couple months back, Dave Linthicum read it and said, "I see this every day, and the complexities of cloud computing and the chance of human error will bite you in the butt." And we see that every day. I saw that when I was at AWS prior to founding Fugue. And so today we're going to go over a couple approaches to deal with this problem. But I want to describe the problem in a little more detail according to the respondents to our survey, not just according to us. So first of all, these risks are very real. According to Gartner, somewhere between 80% and in the future over 90% of cloud security breaches are due to misconfiguration of cloud resources by the users of cloud, by cloud customers. So the cloud service providers actually do a really great job of securing their environments and their kind of core infrastructure. And they give you a lot of capabilities, a lot of features, but if you don't get those features just right, you can end up on the front page of the news, as these are examples of. So that's what we're trying to avoid. So why does this happen? It's because the cloud creates new security challenges. So the cloud is made of API-driven infrastructure. True clouds have no direct manual human intervention. You make API calls to do things like create networks, instantiate compute instances or servers, build firewall rules. These are all API calls. And that means that they're much more dynamic than in the data center when you had to go procure a piece of hardware and go through a change control board and configure it and put in a ticket to change a configuration. These APIs kind of giveth and taketh away. And what they give is flexibility, speed, the ability to innovate, the ability to out-innovate your competitors. What they take away is the friction that was in the process that was needed to make sure you were doing things in a safe and secure way. So adding to that is, as we all know, every year the cloud service providers announce a bunch of new services, new features, and those bring about new sets of knowledge you have to fully understand. You know, what are the security and policy implications of Lambda or IAM? And the combination of these two things, the infrastructure moving very fast, largely driven by developers and DevOps, and lots of new stuff appearing, leads to a lot of challenges at scale. You know, what's running where? Is it in compliance? Are we adequately addressing risks in a timely manner? So we're going to delve into those challenges. But first, according to our survey respondents, this is what's causing cloud misconfiguration. 64% human error, 54% lack of team awareness of security and policies, and about half saying lack of adequate control and oversight. You can see all of this as human error. And I would argue, you know, it's easy to say, well, if our people were smarter, if we didn't make mistakes, we'd be okay. But I don't think that's a fair assessment. These environments are so fast moving and so complex that human beings are just ill-suited to keeping track of all this and making sure it's right. So it's kind of an unfair thing to blame the cloud customer too. Really what we need is some kind of automation and tooling. So again, from our survey, the common types of misconfiguration, identity and access control is a big one. Security group rules, also can think of them as firewall rules, another big one. Object storage access policies and encryption. So these are substantial threat surface. And in the past, a lot of folks in security thought about perimeter and endpoint security, but on the cloud, configuration security, getting things right into policy is really where you need to focus. So what are the challenges in managing these misconfigurations that inevitably occur? Again, more than about half human error, another almost half a challenge of training team members on misconfiguration, which is another form of human error. And then on the right, false positive alerts, right? If you don't have a good solution in place for understanding what matters and what doesn't matter in terms of misconfiguration, you end up with the last one, alert fatigue, all kinds of things coming across your desk that actually don't mean anything. And that leads back to human error, right? Because we now have to manually disentangle those. So we at Fugue like to talk a lot about the mean time to remediation. And what we mean by that is from the moment a misconfiguration occurs that exposes you from a security and attack surface perspective until it is actually fixed and verified. And the process the industry often describes for this is the detect, identify, repair, verify process. So first you have to notice something's wrong. Then you have to have somebody actually identify that, right? So you might have a detector that throws up one of those alerts, maybe a false positive, maybe something real. That's identification. Somebody then has to go repair it, and then somebody has to verify it. And right now, what we're seeing out there, according to our survey results, is almost 90% are saying it's often a day or longer. And that's just way too long. So, and that's recognized by folks in the market. So more than half are saying the ideal would be less than 1 hour. Well, the only way you get there is through automation. This also is expensive. Every time an alert comes across, you're going to take minutes of FTE hours by highly skilled people. I won't read this whole slide to you, but I'm sure if you're attending this, you're here because you know that this is painful as well as very slow. So our goal, we believe, is to have resilient cloud security. And what we mean by that is that cloud security should cover all critical cloud resources and related security rules. Those things have to be considered together in a single source of truth and trust. And then to recover automatically from misconfiguration events, whether due to human error, pipeline deployments with inadequate testing, or malicious actors. So what we want is to have a good, solid knowledge of what's right, what's in policy, what's in compliance, get everything correct, and then the ability to recover to those known good states very quickly and automatically. So there are really 3 current remediation methods. Manual is pretty straightforward. You sort through a list of alerts from an alerting system of some sort, and you put tickets in a ticket tracking system for a human being to go out and make some changes, and then you've got to make a report manually back to the organization. That's kind of the old school way. So we're now seeing two new ways, both involve automation, but they're radically different in how they work, how complete they are, and what it's like to live with them in the long run. We're going to talk about both. The first and most common are automation scripts. So automation scripts are typically things that get triggered by an alert. Like, hey, a security group got opened on a security group ingress rule got opened on a security group to port 22. Somebody somewhere in the organization might have written a script, and we'll show you some of these, that knows when that gets detected, I should go turn off port 22. The third way, and what we do, is self-healing. And in self-healing, you're really shifting left the decisions on what the environment should be like. Rather than reacting after the fact to error, you're agreeing upon with all the stakeholders, the developers, the ops folks, the compliance people, the security people, what is a known good baseline. And once everyone has come to agreement on that baseline, you can then, with an autonomous system such as Fugue, detect drift from the baseline and revert back to the baseline. So with this approach, you buy in up front, you shift all the decision-making left, and the automation doesn't require you to go write a bunch of scripts. So we think manual is kind of a thing of the past. It's too slow, it's too error-prone, and it doesn't scale. And most of the folks that we're talking to who are still doing things manually, it's because they've burned themselves. Well, one, either they haven't gotten to the point where they understand they need to automate because they're early in their cloud journey, or the automation scripts approach has burned them somehow because it doesn't involve all the stakeholders, it's after the fact. So what we're now going to do, I think that sets the stage pretty well. I promised only light wounding, not death by PowerPoint. So we're going to go on and talk about automation scripts and self-healing through some demonstration and code. So I'm going to turn it over to Ricardo to do some chaos on our cloud infrastructure.
Thanks, Josh. Let me share my screen. And by now, what you all should be seeing is a risk manager dashboard with my environments laid out. And you know, for the purposes of this conversation, I want to bring you to this particular environment, which is my protected group. So I call it my protected group because this is the portion of my environment that I want Fugue to manage. So this infrastructure, the way it's configured, this is right. From that, I'm going to establish my baseline, which I did yesterday, and we'll see it actually on the baseline established yesterday, as a matter of fact, which is basically telling Fugue this configuration is how my environment should be. If it drifts, I want to be notified. If there's a configuration change, I want you to fix it. So let's look at that in action. So I'm glad Josh mentioned an automated approach, because so many of us now are deploying our infrastructure using infrastructure as code. So as convenient as it is, it also does introduce errors and changes in configuration. For the purposes of this example, I'm actually just going to use the AWS console, and we're going to touch on some of those hot button areas that seem to be prone to misconfiguration. So number one is we're talking security groups. So I've got my security groups here. I've got a couple web applications that I've deployed, but as Josh said, we're going to be a little bit chaotic and break some things. So one of the things we always talk about is port 22 gets opened. So that people can SSH, they want to do updates, they want to push additional code to the environment, maybe sitting at a Starbucks or a Panera and just need to do something really quick. That violates the security protocols that they've established within the organization, but we'll do it anyway. So we basically opened that up to the world, and while I'm in here, why don't I just get rid of some of these other ones? So that's in one of my web apps. And the other web app, I'm actually going to do the same thing. I'm going to make it a little bit worse, though. I'm just going to open up to everything. So pretty much anything that wants to access this is going to be able to access it. And we'll go ahead and shut these two down as well. So that's bad. Basically, my application is now shut off from the world. So nobody can access my web app. If it's revenue generating, that's a problem. So we're going to get some alerts, and some folks are going to have to get to work on that. Now we'll just screw around with the auto scaling groups. So we've got this set up to scale. So there's certain parameters that'll scale. We want 2 instances as our desired. What happens if we screw that up? So we'll actually, since we're in a chaotic mode, we'll just shut those down completely. So now we've got an auto scaling group of 0. So basically I'm telling my auto scaling group there should not be any instances, everything is shut down. And then when folks try to find it, as we all know, a best practice within AWS is tagging your infrastructure. So now when we try to identify that, the tags, they're gone too. Big problem. So let's look at some of the other things that are often misconfigured. So we talk about S3. I'm going to stick in the US West 2 region, which is where we are. We'll just touch on this bucket. So from a properties perspective, I have encryption turned on. So from compliance, for security, you name it, you want to have all of your objects in your S3 buckets encrypted. And I'm going to change that. And Josh, I hope you don't mind me taking up extra time, but I'm going to jump into one of my VPCs. So we talk about infrastructure as code. When you're writing infrastructure as code, you're typically going to declare a variable for your various VPCs so that you know when you're deploying your infrastructure that it's deployed in the right VPC, and that's usually done by the name. We're going to look at this and we're just going to change this name. So we'll make this Josh VPC. So now when we deploy our infrastructure as code, we're actually going to run into some issues there because whatever it was named previously is no longer there. And so we've made those changes. So Josh, I'm going to turn this back over to you. Hopefully I've introduced enough chaos for us. I'm a little nervous. And I know a lot of folks that manage infrastructure on a regular basis would be quite nervous with the amount of alerts and things that would actually have to be attended to by making those changes. So we'll come back and revisit that a little bit later.
Thank you, Ricardo. I'm going to switch to sharing my screen again here. And I'm going to jump over to how remediation with automation scripts work. So we're bouncing back and forth a little bit. I'm going to ask you to remember what Ricardo just showed you is the beginning of the self-healing approach. I'm going to dive a little into remediation with automation scripts. And so before I start showing you code, it's important to understand how this approach works. So you just saw with self-healing, you define a baseline and you click a button that says turn on enforcement. And then any changes to that environment, no matter what they are going to be fixed. They're going to be remediated automatically. I'll point out a little bit more on that. What most folks who use self-healing do is they choose a sort of subset of their overall infrastructure for this level of autonomous kind of automation. Typically the scary attack vector parts, you know, Ricardo did a good tour. VPC, security groups, auto scaling groups, on the other hand, are about cost, but you probably care about that too. So how does this work in the alternative approach with automation scripts? So the first thing you need to do with automation scripts is you have to write code for every scenario where you want automated remediation. And this will make more sense as we dig into it. But you're going to need to write a script that does things like turn off individual ingress ports on security groups. You're going to have to write another script for doing things like making sure VPC names stay the same. So your first step is to develop and deploy those automated scripts. A lot of folks also call them bots. It's the same thing. So then step two is the scanning tool you're using needs to identify misconfiguration, right? So you're scanning through and now all of a sudden that security group having a new ingress port is noticed by the scanning tool. I'll point out that most scanning tools aren't really great at detecting things like VPC name changes, right? So you have to be very thoughtful about making sure you're capturing everything. And then step 3 is when that scanning tool sees that problem, it can then call that script that you wrote or bot to make a correction or a remediation. So the workflow is quite different. But let's dig into some scripts. So I hope you can all see my code editor here. I've just gone online onto GitHub and downloaded a open source collection of remediation. They call them bots in this case. And so let's take a look at what this approach ends up living like, ends up being like to live with. So down the left, you can see I've got a collection of different scripts, and they're pointed at very specific things. And I'm going to walk through just a few of these. And since we did some security group rule deletion, or we're going to with self-healing, let's look at what that looks like as a script. So you can see here at the top, and by the way, this is just Python code. If you're not a programmer, I'll try to put it in really plain English. If you are a programmer, you'll recognize that this is just writing photo scripts, which is a library written by an AWSer to be able to manipulate cloud APIs. But there's a lot of notes up here, conditions and caveats, and it's going to tell you all the ways it may or may not work, depending on what happened. So in the self-healing approach, because we have that known good baseline, we always know what's right, and we can remediate to it. In this approach, you don't have a known good baseline, so you're having to guess at what might happen and account for that in all this code you're writing. And you can go out, there are collections like the one I'm showing you of these bots or scripts that you can download. You're going to find that you probably need to modify them, that it's probably not complete. And so what the automation scripts approach, one of the negatives to it is you're now maintaining a large code base over time, especially as you get more sophisticated. So my personal view is that this approach can make a lot of sense if you're only trying to deal with a handful of super critical security issues. But maintaining this dozens of scripts, and you can see they're substantial, right? This one, just to close a port on a security group, you're maintaining about 300 lines of code, and those things add up. So here's another one that's a little, it's about 70 lines of code. This thing just deletes all ingress and egress rules from security group. Probably something you generally don't want to do. Here's another one for turning VPC flow logs on. That's all it does. So in the scenario in which Ricardo just demoed to you on the self-healing approach, if anything about that VPC network changes, it's going to be fixed automatically without you writing code. In this case, you've got a couple few hundred lines of code just to deal with things like turning on flow logs. So the other thing I'll point out about this are the number of scripts you're going to have to write and how incomplete they are in terms of covering your overall critical infrastructure. So I think in a mature scaled environment, you're going to be either writing a whole lot of scripts or deciding to handle most things manually still. So a couple other issues around this. There's no longer a single source of truth and trust that's agreed upon by the stakeholders. So it's very typical in a cloud production workflow environment, in a DevOps environment. The DevOps team is probably using something like Terraform or CloudFormation to go build out infrastructure. And in this kind of bot approach, this bot doesn't know anything about that infrastructure as code. It's just going to go change the production environment, which might be quite surprising to the DevOps team. And we've talked to many folks who are scared off about auto remediation because of that exact effect. That this is the shift right approach, right? In the self-healing approach, you've gotten everyone on the same page together, all the stakeholders in agreement and aligned on the baseline, and then you're reinforcing back to the baseline. In this approach, you've got another product down the line that doesn't understand the infrastructure as code, apparently arbitrarily making changes, and then you're back to a human manual process where the security team has done things that are disruptive and potentially to the DevOps team. All that said, if you have a handful of rules that are just absolutely you do not want people to break, this approach can make sense. It can be a way to stick your toe in the water. But I would encourage that as you do so, as you hit scale and you start to hit some of these scaling problems, you consider the more robust self-healing approach. So again, that workflow for remediation with automation scripts. And now let's jump to remediation with self-healing infrastructure. Again, you establish a baseline that's taking a snapshot of the running infrastructure. You can do this, by the way, in the dev environment. That's what we recommend, is getting your compliance, security, and DevOps folks all looking at what that good baseline is in dev, so that it can then be moved to production in that known good state. But once it is being monitored and self-healed, the misconfiguration is identified. And it's also important to point out what's meant by misconfiguration in a self-healing baseline environment is different and better than what's meant by misconfiguration in a no single source of truth and trust, separated concerns environment. In a baseline environment, a misconfiguration is something that has changed from what all the stakeholders have agreed upon. In the other kind of environment, right, in the scanning remediation environment, security might see something as a misconfiguration that development said is what we actually need. And so this, again, pushes it left. And then, of course, in self-healing infrastructure, the automated remediation is fired in order to get back to that known good baseline. But why don't I pause here, and Ricardo, are you ready for me to turn it back over to you?
Yeah, and while we return over to Ricardo, we put another poll question up on the screen. We're curious about what methods your team is using to address cloud misconfiguration. Are you doing it all manually? Are you using automated remediation of some kind? Or are you doing some kind of mix, a little bit of manual, a little bit of automation scripts? Thanks.
Perfect. I am ready, as a matter of fact. So I will go ahead and share again. So what we're looking at here is we're back into my risk manager dashboard. I've focused on my drift events. Again, as Josh mentioned, it's just a matter of enabling enforcement, establishing that baseline. And I'm not going to bore you with digging into all of these reports, but I will just take a look at the time. And I'm not sure exactly what time that I made those changes, but within the last 10 to 12 minutes, give or take. But if we go down the list and just see what's happened recently, so some of what was auto remediated, and I'll click on a couple of these, but we'll see a security group change. We see an auto scaling group change where things drifted, and these were the auto scaling groups that I shut down was at 0, and the remediated attributes back to 2, 2, and 2. We have our tags, so I can identify that infrastructure again. Those tags have been reestablished. The VPC itself, sorry, Josh, I tried to change it to Josh VPC. Didn't quite work out. Fugue caught that change and reverted it back. So now my infrastructure is code files that I am going to reference the Fugue Inc. network to deploy additional infrastructure will work properly. But as opposed to looking at the dashboard, why don't we jump into the console? Because that's kind of like the proof is in the pudding. Let's see what the updates were in the console. I have the list here. First, we started with the security groups, both of them affecting the ingress for Fugue Inc. Security Group 2. We see this has been reverted back, so port 80 and 443. So we have our access again. If we jump down to the other one that we cut off the internet access to, we see port 80 and port 443 have been restored as well. So all is fine. We have access again. Our web apps are communicating with the rest of the world. We already talked about the auto scaling groups, but we'll go ahead and show you in the console. We see that this is back to 2, 2, and 2. The tags that we established are there, which is great. Let's go over to our S3 bucket. Filter the region. I'm not sure which bucket it was, but we'll look at both of them from a property perspective. Encryption is back on there, which is perfect. That was in test bucket 1. We'll look at test bucket 2 as well. Properties, encryption is turned back on. And last but not least, we'll look at the VPC. And I'm not sure which one I named Josh VPC, but it doesn't really matter because they've all been returned back to the names that we established when we deployed this infrastructure. So as you can see, we didn't have any scripts. We simply established the baseline when earlier, you can see the date that the baseline was established, which is yesterday afternoon. And essentially, we're going to have a report from the drift events. So everything that's changed and been remediated, we have a report there, and we're back to operational status. So literally, going back to one of Josh's slides, which talked about the mean time to remediation being hours and in some cases days, we're down to a matter of minutes for this protected group of infrastructure. So literally made the change and less than 10 minutes later, we're back up and running. So you can see the self-healing approach was quite simple. It was a matter of clicking buttons, Fugue catches the drift events, puts things back to that known good baseline, and we're back and operational. So I'll turn it back over to you, Josh.
Thank you, Ricardo. I'm going to go back to sharing my screen. So again, you just saw how remediation occurs with self-healing infrastructure. I want to make another point here, which is, and this is really about, oops, I hit the wrong button, bridging the divide between the different groups with a single source of truth. So I want you to imagine for a minute that your DevOps team has written a bunch of Terraform or CloudFormation, and they've checked it into their Git repos. You now have infrastructure as code, or you think you do. Then you start employing automated remediation scripts that don't have that single source of truth. And what's out in the environment has been modified. And so if you go and look at that infrastructure as code, it is no longer reflective of what's in the environment. So it's really not your infrastructure as code in that approach, it's your initial configuration as code. And that creates rifts between these groups because there is no single source of truth. So with the self-healing approach, compliance teams get visibility and reporting for their entire cloud footprint, right? We focused here on self-healing, but you can also use a self-healing system like Fugue to just alert you and notify you on these drift events and to compare them, in Fugue's case, to things like NIST, PCI, HIPAA, GDPR, CIS benchmark, so that the compliance teams can have comfort around what's being deployed. And you can do that in dev as well as in stage and prod. The security teams, by using self-healing on the most critical infrastructure, can protect critical cloud resources from data breach. And this is done in collaboration with the DevOps and infrastructure team because you're catching it early, you're shifting it left, you're agreeing on that known good baseline. It also allows the security teams, of course, to catch all the things that might change rather than just those things they thought about writing scripts for and are now manually maintaining code for. And for the infrastructure teams, we've been talking a lot about security, but some of what Ricardo showed was breaking systems, not necessarily security holes, but just making systems not work anymore. And one of the really nice side effects of the self-healing approach, actually one of the desired outcomes of the self-healing approach, is it's not just policy and compliance and security issues that get remediated. It's not just the scripts that you wrote to target very specific things. It's also if that configuration drifts to a state where the business function is damaged, it can be automatically, autonomously corrected. So with Fugue, we're a SaaS solution for this resilient cloud security. You can get started with us in an hour or so, in which we scan your environment, detect infrastructure drift once you've established a baseline, and then if you choose to turn on enforcement or self-healing, automatically enforce. We have a lot of great customers and partners. We're an AWS Advanced Technology partner in cloud governance. We have been working with folks like In-Q-Tel, and a lot of the Fugue philosophy came out of working in national security environments to build really high trust systems. But we're very proud of our awesome partners like PBS and customers, Unisys, SAP, NS2, Global Giving, SparkPost, etc. So let's pause here and see if we got any questions. Drew, I'm going to turn it over to you.
Thanks, Josh. Yeah, we got some. If anybody has a question, you still have time to get it in. And if we don't get to your specific question, we know who you are, and we're going to reach out to you after this webinar and get you an answer to your question. So first one is, we've implemented some Lambda scripts provided by our security tool, and want your opinion on at what point do you see this approach becoming unmanageable?
Well, there are a few symptoms to look for. Okay, the first one is that you're investing more and more time into this. And I would argue that writing these Lambda scripts is actually not generating business value for your organization, right? So the goal of security is to keep things safe while the organization realizes its business goals. So if you're an AWS customer and I'm an AWS X principal solutions architect, we used to talk a lot about undifferentiated heavy lifting. And what's meant by that is you're spending your time doing something that actually doesn't go straight to the goals of your business. So if you find yourself investing a lot of time in these Lambda scripts, that's a sign that you're crossing the line. Other things we've seen are when these things create friction, and you know, in programming we would like to talk about the principle of least surprise, right? What we mean is we want our systems to behave predictably. We want, when we say this thing should happen this way, we expect then it will happen that way. And I've often seen teams start to implement these kinds of Lambda scripts, and it generates confusion back to the developers, because you know they asked for an S3 bucket configured a certain way, and it changed on them magically, and now their application isn't working. Well, this is undesirable for a number of reasons. One is it creates distrust in automation. But if you can't automate, you're going to fall behind your competitors or the bad guys who are coming after you. And so that's a really pernicious kind of organizational breakdown. The other problem with it is, even if you choose to keep forging ahead, you now have a lot of friction, latency, and therefore cost, because the groups have to manually talk to each other about what's happening on a case-by-case basis, or send out a policy statement saying, the new policy is, we've put a script in place that is going to shut down internet gateways on VPCs, or whatever it is. So these are symptoms that you're hitting the wall with the Lambda scripts approach. I hope that answered the question.
Great. We'll reach out if it didn't. But thanks for that. That was good. We just got one here that I think is pretty interesting because I know we've got a lot of Terraform users out there. Cristobal asks, why would you write extra Python scripts to enforce the state of what your Terraform code has defined? Why wouldn't you just run a Terraform plan in a loop and alert when there is drift?
Yeah, it's a good question. If you are extremely fastidious about your use of Terraform, I've seen that approach work. However, whether it's Terraform or CloudFormation, you can get into scenarios where automatically running them in loops creates unintended side effects, creates consequences that you didn't predict. So, for example, with Terraform, you can get into conditions where the state file has not kept up with what's happening in the actual infrastructure environment, because typically the state file is only an expression of what happened during deployment. So that's one thing. Another thing is it can be quite difficult to understand where a Terraform script is going to violate policy or compliance. And so something we really didn't get deeply into in this talk, because this is specifically about self-healing infrastructure, is the ability during that development period. So let's say you write a Terraform script, you run it in dev, then you use something like Fugue or another scanner that can show policy and compliance. That gives feedback earlier in the loop as to whether or not that Terraform is going to be correct. But the main reason I have seen people not using either Terraform or CloudFormation in a fully automated way case of Terraform and of CloudFormation, they are only concerned with the resources and the configuration items on those resources which you specifically call out. So for example, if you define a security group in one of those tools that has certain ingress rules, and somebody manually goes and adds another ingress rule, both Terraform and CloudFormation are only looking at whether the ingress rules they created are correct. And so it is very common for these kinds of drift to occur outside of the scope of those initial configuration descriptions. So if you look at, for example, CloudFormation now has a feature where you can go and say, well, I want to click a button to put it back to how that stack ran. But if you read the fine print, it will tell you it only pays attention to the resource configuration items that were absolutely specified in the initial run. So if you have, for example, a security group that has HTTP and HTTPS open and not SSH, and you don't, that SSH should be not open, which you probably won't, because that's going to be a very long list of things to never do, it will not see that as drift, and it will leave it alone. So I'll pause there and see if we have any other questions.
Yeah, isn't Fugue just using automation scripts under the hood?
No, absolutely not. Absolutely not. So the way Fugue works is radically different. Under the hood, and I won't get too far into the details, into the weeds, but the way Fugue works is we establish a known good state of every single resource in an environment. And when I say every single resource, I mean everything accessible via the Cloud API. So we know not just what's in the Terraform state file, which is what Terraform did to the environment, for example, and not just a list of scripts. We do not have a bag of scripts inside Fugue. Instead, we have a highly sophisticated state machine that can examine the environment in its totality. And then every time a scan is run, we look for any change. So for example, there is no script in Fugue that looks for VPC names. we know everything about that VPC that's accessible via the AWS API and soon also Azure. And then we compare that to the current state. So no, it is absolutely, we would never be able to keep up if we were using that approach. It's just a Sisyphean approach of rolling a rock up a hill and it rolling back down as new features are added and so on. So with Fugue, when we have service coverage, we automatically have self-healing for that entire service.
Okay, great. We'll take one more here. I think this is pretty relevant. How can a security team get buy-in from the app team to do security automation?
Oh, I love this one. So one, I think that a lot of this is organizational and process oriented. So I'm seeing more, and I'm very encouraged by this. And we actually just put up or are about to put up a post on DevSecOps. And a lot of what that post is about is how to do just that, how to get folks on the same side of the table. But to get folks on the same side of the table, you need a single source of truth and trust. You need a single place where all stakeholders can agree in advance on what's correct and what's not. And you need automation. So from a practical perspective, that means the security team needs to either through training or hiring, add folks who understand development, and get embedded in the CI/CD tool chain, in the DevOps process, and build trust in this way. And then the second part of that is step into it incrementally. Don't jump straight to self-healing or automated remediation across everything. Hit the things that are the most critical first. I was working with a customer recently who said, you guys helped us bring security and DevOps together because, not because of security, but because of using Fugue with self-healing. We no longer have the problem of different development teams breaking the VPCs in ways that hurt other people's applications. So I think that with this kind of approach, where you're embedding with them, where the teams are brought together, on a human basis, and sharing how to operate and how fast to go in different places and how aggressive to be in different places, you build trust, you build agreement among stakeholders on how to approach it, and that gets you on a path to getting further and further down the road of automation as you step into it.
Okay, great. We've got some super specific questions. We'll reach out to individuals directly to answer those, and we'll move to wrap.
Well, great. I want to make an offer to all of you awesome folks who came and attended this webinar, which is if you reach out to us, we are offering two things today. One is, and in both of these take about an hour of your time, that's it. If you reach out to us, we can schedule an hour where we will sit with you and do a workshop where we only need read access from Fugue. You're not going to be granting us deep access to your environment, where we can work with you to lock down your security and critical cloud resources. We can do that in an hour. You don't have to turn on self-healing during that hour. You can have it be in monitor-only mode. But if that's interesting to you, reach out. If you're a compliance person, or if this just appeals to you more, similarly, if we schedule an hour, we will sit down with you and do a free compliance audit of your cloud environment. And we can do that compliance audit against NIST, PCI, HIPAA, GDPR, CIS benchmark, or all of the above. And so we hope to hear from you. You can reach out at these hello@fugue.co, or just go to our website. And with that, thanks very much for your time.